at Panchkula, and co-chairperson Professor Ajay Kumar Dugal, Associate Professor NITU Chandigarh. I also welcome honorable speakers Dr. Sunil Bose, Engineer Vidurkant Jha, Dr. Anush Kesi, Assistant Professor Thapa University, and Engineer Inderjit Ghai and the learned audience. This session is devoted to technical presentations. Audience is requested to jot down their queries as all questions will be answered in the post-lunch session dedicated for the question and answers round. With the permission of chairperson and co-chairperson, we now start with the technical session. First lecture is being presented by Engineer Inderjit Ghai on the topic of Introduction to Terms Used in IRC 37-2018. Engineer Inderjit Ghai is Managing Director of General Highways and Infracon Private Limited, previously Consulting Engineers Associates, an eminent civil engineering consultancy organization providing servicing since more than 18 years. This consultancy was started under the dynamic leadership of Sir, who had more than 34 years of experience in contracting and consulting business in India and abroad. He is also the chairman of Civil Engineers Academy and Research Center, a non-profit making registered body for the interface of highway engineering with the society. The aim of this society is to upgrade the knowledge and skills of professionals related to civil infrastructure jobs by way of holding workshops, providing training through capsule courses tailor-made as per the requirements of the industry to minimize the gap between qualified engineer and employable engineer. In the past, almost all engineers of Haryana State Agriculture Mandi Board have been trained in design and construction of flexible pavements, and newly recruited engineers of Punjab government since 2011 have been trained in use of modern surveying equipments. A workshop was conducted by this society in 2018 at Chandigarh on planning, design and construction of elevated grade separator with wide deck and central pier in urban areas. In recognition to his contribution to the highway sector, he was selected member of IRC H2 committee for flexible pavements, airfields and runways in April 2015. He has attended all the meetings of this committee from 2015 till date and contributed in revision of this IRC 37 code. Sir, you are requested to deliver the lecture.
Dear friend, I again welcome you in this technical session. I am aware that everybody present in this auditorium knows the basic terms used in IRC 37, and everybody knows that warming up is must before start of actual exercise or any game. So, to refresh your knowledge and to warm you up for the upcoming lectures, I will give this brief presentation on the various terms used in IRC 37. Basically, flexible payment, everybody knows. In the second slide, we have shown that this is a flexible payment. Once the vehicle moves, it comes back to its original position. So that is why we called it a flexible payment. So typical cross section of flexible payment, conventional payment which we use Again, I say that I am just refreshing your knowledge. Most of the people present over here must be feeling that they are already aware about these things, but I will hurriedly explain these things to you. So these are natural ground, subgrade, sub-base course, base and wider course, and surface course. So these are the conventional, typical section for conventional payment which we use in highways. So with the treated material which we call smart payments, now in the subgrade, even we treat the subgrade also to increase its CBR value. In coming sessions, you will come to know that to what extent can we increase the CBR value and to what limit we are to use that CBR value in design. Then we can treat the subbase also. That is cement treated subbase. You can treat it with cement, lime, or chemical admixture. Then base course. पहले जितनी हाईवे थी अगली लेयर डाल दो, नेक्स्ट लेयर डाल दो. स्पेसिफिकली इन द सिटीज सड़कें इतनी ऊंची हो जाती हैं कि लोगों के घर नीचे हो जाते हैं. नेशनल हाईवे पे जब जाते हैं तो अब देखने को मिलता है, अब तो सभी लोग उसको रिक्लेम कर रहे हैं, लेकिन लगभग मीटर पौना मीटर थिक बिटुमिनस की लेयर नज़र आती है. सो रैप अभी नेक्स्ट प्रोग्राम में एक्सप्लेन करेंगे कि रैप इज़ very useful, and even IRC 37 have clarified where to use it and how to use it. Then comes the aggregate interface layer, flag relief layer, then is the base and binder course, then the surface course. So upper two courses are same, but in these upper two courses also, as Dr. Tanuj informed, they are using other materials also, which we will explain in the next slide. So just for a reference purpose, in conventional payment, considering that a CBR value of 8% and we designed it for 30 MSA, almost the thickness used to come to 585 mm. But when you go with this treated subbase, which we call smart payments, this thickness can come to 400 to 500 mm. So I explained the different layers. So layer 1 is embankment, it is natural existing surface filled up material. Either you have the existing ground, if the ground is lower, we create the embankment, then we do the filling, that is the filled up material. Second layer comes subgrade, it is in situ material, selected earth material, stabilized soil. If the level permits you need not import the earth, you can use that layer itself as a subgrade, but you will have to bring it to the design parameters of CBR to that soil. Next layer is subbase. In conventional base, it is GSB. If you treat it, it is then becomes GSB or say cement treated subbase. Third layer is wet mix, the waterbound macadam, cement treated base, CT or RAB. So these are the basic words which in next presentation they will use these words very frequently. That is why I am explaining that these are the words which will be used in the base course. Then binder course is DBM and BM. In our fifth revision, they have removed BM, but I think they are again going to introduce BM. Then the surface course is BC, SDBC, PMC, MSS, SMA, GGRB, SD or BC. So these are the words which will be used by them. Bituminous course, semi-dense bituminous course, and mixed steel surfacing, stone matrix fault, gap graded rubberized bitumen, semi-dense bitumen and bituminous concrete. So first layer we discussed, it was the embankment. So it is a natural ground filled up soil on which subsequent pavement layers are placed. So if the level permits, it can be natural ground also. If you are to raise the level, then you have to import the material, that is the embankment. Then comes the subgrade. As I already informed, subgrade it is the minimum thickness required for subgrade is 500 mm. If the level permits, you can use the existing ground itself. You are to lose it and recompact it to bring to the designed CBR value. Or otherwise, then you have to import the earth of the design CBR value. So subgrade has a design CBR value. Then comes the granular subbase. In granular subbase, In revision 5, most of the people are aware, they have removed RBM. जो GSB में पहले रिवर बॉर्न मटेरियल होता था, पर रिवीजन 5 में उसको क्रश्ड एग्रीगेट लिखा गया था और काफ़ी कंट्रोवर्सी रहती थी कि ये क्रश्ड एग्रीगेट ही यूज़ करना है GSB के अंदर, सॉरी WMM के अंदर. GSB it can be RBM, it can be crushed stone, RCC or laterite. In GSB, yes, in GSB there was a controversy. Now in this IRC 37, they have clearly mentioned that you can use RBM also. Then wet mix macadam, it is, everybody is aware that it is a clean cut aggregate 45 to 75 mm size, and it is pre-mixed with water in a plant and transported to site at OMC and compacted over there. Then, as I informed you that there is treated subbase. So to have a perpetual payment or long-lasting payment and to reduce the thickness of the material, you can go with the treatment. It can be either with cement, it can be with lime, or it can be with chemicals. So this is one of the photographs showing that treatment is being done. Then bituminous layer, DBM, dense bituminous macadam. DM is bituminous macadam. It is allowed up to traffic of 20 MSA only. Surface course are BC, bituminous concrete, GGRB, gap graded average bitumen. SMA stands for stone matrix asphalt, MA for mastic asphalt, SDBC, semi-dense bituminous concrete. EMC stands for pre-mix carpet, MS for mixing surfacing, SD for surface dressing. Most of the layers have been used by most of the engineers present over here. Then reclaimed asphalt pavement. As I told you that this is a new concept, but since last 5-6 years it is used very frequently on almost all highways. So this is a machine. With this machine they reclaim the old asphalt. Then the old asphalt material is used either as in wet mix macadam or in bituminous layers also. Then one layer was crack relief layer. When you use this smart payments, there is the necessity of this crack relief layer, which can be either a layer of aggregate or it can be a stone matrix which we call SAM. So this is the soil classification which we have explained: fine grained soil and coarse grained soil with the size of the sieves. Then for design of pavement, the word used is CBR. I think everybody is aware CBR is California bearing ratio. So CBR, it is basically, there is stone in California which when they test as per this procedure at 2.5 mm settlement, the load which comes on that stone at 2.5 mm settlement, it is 1370 kg, and again 5 mm settlement, it is 2055 kg. So they have declared the stone having 100% CBR. So with that method, we use this, calculate the CBR. It is generally it is soaked CBR, which is considered in the design of the flexible pavement. Then other words which they were using is the axle, single axle, dual axle, axle load. So we have in this picture, we have tried to explain that axle. Generally, we design the pavement, structure design is carried out for vehicles having load of more than 3 tons. It is sometimes confused that this is 3 ton is the load which is added in the truck or tipper. So this 3 ton includes the weight of vehicle also. Then comes the axle. This is axle. Every vehicle has 2 axle. One is front axle, second is the rear axle. Then a rear axle, we have the single axle dual wheel, tandem axle and tritandem axle. So these are the photographs: single axle, tandem axle, tritandem axle. So then they will be using the word traffic terminology. They will be using the word vehicle damage factor. So this is the formula by which the vehicle damage factor is calculated. But in our code, it is provided that in case you have not done the axle load survey, you can use this vehicle damage factor from traffic 0 to 150. It is 1.7 for rolling terrain, 150 to 1500, 3.9, and more than 1500, it is 5. Earlier in IRC 37, 2012, these values were less. Keeping in view the overloading we've done on the highways, these values have been increased and changed now. But it is, for important project, it is always better to do vehicle, do the axle load survey and find out the actual vehicle damage factor. So, in this last IRC journal which we get, the editor has published this thing that if a vehicle having single axle, means one front axle, one rear axle, if it is having a total weight of 25 ton, approximately 6 ton weight comes on front wheel and 19 ton goes to the rear wheel. The vehicle damage factor is 30 ESA. And if the same load is carried out by a vehicle having tandem axle, this VDF goes to 3.2. Now we can imagine how much damage is caused by overloading. It is almost 10 times. Even increasing is axle in that vehicle reduces the vehicle damage factor by 10 times. So one other thing which we use in the design, generally we get confused with that is which traffic is to be counted. And that is then, it is a lane distribution factor. We are to count both side traffic, up traffic and down traffic. If it is a single lane, 3.75 meter width, you are to count both. It is indeed number to be counted as commercial vehicles only. Vehicles having load more than 3 ton. So you are to count both up and down traffic. If it is 3.75 meter wide road, you are to add both the traffics. That means the lane distribution factor is 1. And then if it is 5.5, then you add both the traffics up and down and multiply it by 0.7. In other words, the lane distribution factor which we use in that formula, it is 0.75. And it is 2-lane road, it is 0.5. 4-lane road without any median, you are to add up both up and down traffic and multiply it by 0.4. And in case there is a median in between, for 4-lane vehicle, you are to count either up or down, whichever is more. Or you can have different designs also. If it is lot of difference, you can have different design for up and up lane and down lane separately, but generally it is not done. So we do design for the traffic which is more in any lane. So you have to count traffic in up lane and down lane, whichever is more, any of you that is to be used, and it is multiplied by 0.75. Then dual 3-lane, same, it is 0.6, and dual 4-lane. So the roads in which we have median, the word used is dual. If we do not have the median, then it is called 4-lane single carriageway. And if median is there, then it becomes dual 4-lane carriageway. So that factor is 0.45 into any one of the traffic, either up traffic or down traffic. We have given these details in the small notebook which have been given to you. These details are there also. Then Dr. Chopra was mentioning about rutting. तो ताकि सिंपल लैंग्वेज में आपको नज़र आ जाए, इस चीज़ को हम रटिंग बोलते हैं. जब हैवी व्हीकल चलते हैं तो पेमेंट बीच में इस तरह से ये शेप ले लेती है. तो ये शब्द काफ़ी ये अपने डिज़ाइन में यूज़ करेंगे रटिंग. तो मैंने पिक्चर के थ्रू दिखाने की कोशिश करी है कि इसको हम रट बोलते हैं. दैन एक जो वर्ड यूज़ करें दैट इज़ द फटीग. सो फटीग बेसिकली क्या है कि जब आपके पास बार बार उसके ऊपर लोड जाता है तो लेयर्स में कुछ ना कुछ डैमेज होना शुरू हो जाता है. तो अल्टीमेटली इट गेट्स टर्न्ड इनटू क्रैक्स. सो दीज आर द फटीग क्रैक्स. डिफरेंट photographs have been shown to explain the word fatigue. So these both words they will be using, rutting and fatigue. So in the fatigue then they will use the word top down cracking or bottom up cracking. ऊपर से अगर क्रैक नीचे ट्रैवल कर रहा है टॉप डाउन क्रैकिंग है, बॉटम अप क्रैकिंग नीचे से ऊपर जा रहा है तो बॉटम अप क्रैकिंग. देन एक जो यूज वर्ड काफ़ी वर्ड यूज़ करेंगे दैट इज़ द मॉडुलस ऑफ रेजिलेंस और रेजिलेंस मॉडुलस. So हमने सबने पढ़ा है model of elasticity, everybody knows stress over strain. So this is the stress, force over area, strain is change in length, what is original length. And modulus of elasticity is stress over strain. Whereas the modulus of resilience, it is almost modulus of elasticity, but it is a stress divided by strain for a rapidly applied load. So Dr. Bose and Mr. Jha will explain it in detail. So generally we get confused what is the difference between modulus of elasticity and modulus of resilience. So modulus of resilience is stress divided by strain, but it is for a rapidly applied load as is considered in highways and pavements, and it is calculated by traction test. Then they will use viscosity. ऐसे सभी को पता है विस्कोसिटी के बारे में, लिक्विड पतला है तो विस्कोसिटी कम है, लिक्विड थोड़ा सा गाढ़ा है तो उसकी विस्कोसिटी ज़्यादा है. तो जैसे पानी की विस्कोसिटी कम है और ये बिटुमन की विस्कोसिटी ज़्यादा है. So ये वर्ड भी यूज़ करेंगे. Then CRMB, it is a crumb rubber modified bitumen. There are 3 grades. So in the bitumen, to modify the bitumen, they add crumb rubber. People from Tina industry are here. Anybody who wants to know about the CRMB, they can contact them. Then there is polymer modified bitumen. There are so many chemicals about which I am not expert and I am not very much aware also. They add these chemicals and it becomes polymer modified bitumen. But all these specifications have been given our codes now. Then the word they will use Poisson ratio. Through the slide show, we have tried to explain the Poisson ratio. And the Poisson ratio, mu, the value as per code, it is 0.35 restricted to 0.35 for sub-base, untreated sub-base, base and bituminous layers, and 0.25 for treated sub-base and base layers. So this was ABCD of IRC 37. I got motivated for this ABCD. There was a movie, ABCD, anybody can dance. But now our mission is ABCDE, awareness between civil degree diploma engineers, for which we are conducting this workshop, and we will put our best efforts to continue this workshop, these workshops in future also. Thank you.
Thank you, sir, for the useful presentation. Now, Engineer Puneet Sharma will be my co-host for this session. He is CEO of General Highways and Infracon Private Limited. He has designed many prestigious highway projects throughout India.
Thank you, Avni, and thank you, sir. I hope the delegates have got mentally warmed up with this presentation and now they will easily grasp the upcoming lectures by our experts. Engineer Bidur Jha is M.Tech Transportation Engineering from IIT Kharagpur. He joined Lee Associates South Asia Private Limited and is currently General Manager, Payment and Materials. He has altogether 19 years of professional experience and his core areas of expertise are investigation and evaluation of existing payments, material testing and characterization, value engineer design of new payments, and long performing rehabilitation and maintenance design of existing payments. Now I request Engineer Bidur Jha for giving his technical presentation on the topic overview of IRC 37 2018.